Hi, my name is David Torno, and in this video I'm going to talk about GeoTracker and show you how I did the effects for the water simulation and the plants. So for this dam with plants clip, I just did a camera track using this proxy geometry. So the actual scan footage here, I just took some frames out from the clip. It was like every 10th frame or so, and fed that into a photogrammetry software. I use Metashape, but there's some free ones out there like Mushroom that you can use, and use that to basically get some proxy geometry. You know, it's not that great on the back end, and that's because the camera angle is pretty much from up here, so that isn't viewable. But this is just enough to use both as a track and as a guide for some geometry that I built later on for shadow catching and such. Basically all I did was kind of transform all of that. I reduced it, clipped it, and cleaned up some of the edges on that just to kind of narrow it down to what I needed. I have an output that has UVs projected on it from the camera view, which is give or take about there, so the footage can be projected on it, as well as the track output from there. What I got on this was pretty much 2 keyframes, start to finish. And it was, since there's enough information there, it tracked it pretty decently right off the bat. I didn't have too much of an issue. And it's, for the most part, a linear move. It looks like this is on a drone, so the movement is pretty straightforward. But I got a pretty decent track on that. The idea being that I'm going to put some water through the little spout here. I'm going to add some vegetation on the front face of this that kind of mimics some of the vegetation that's around there. So I'm going to need some geometry for this front face, for the spout, as well as the top, both as shadow casters and shadow catchers, as well as colliders for simulations. So I was going to have to build some of this geometry as well and use this as a guide. So the track all happens inside of there. And then I just broke out the sims into its own separate thing. The spout geometry, and on this, we can see it. I just made a generic collider, kind of like so. Put some bumps in there just so there wasn't a flat surface to kind of rough up the way the fluid comes through. Nothing too crazy on this. Just a box to get all of that, and then scattered some points with this and converted all the VDB. And that got me the base spout. Now for the shadow catcher, pull this back out, we have something way more detailed here. I'll turn the UVs off. So I had to basically model out all of this, and it's just using boxes and booleans. It's pretty basic shapes for the most part, and curve in this particular case, just so I can get a rounded edge. So it's stuff where I'm just making a right and a left rail, basic curve shape, poly extrude, merging those together, and then using a lot of match sizes to create a joining geometry that's going to be, you know, associated to its location. The top is just a boolean of some basic shapes, and then these upper slats are just a basic shape that's been copied and replicated. And the lower base, same there, and the same for the upper. It's just basic boxes, nothing too crazy. Using match size to kind of snap everything, and then some slight adjustments here and there to make it work from the camera perspective. Once I have all of that there, there's a poly bevel that goes through, plus UVs and all of this. There's a collider, which is a SDF version, and then a geometry version that also has a back wall there for shadow catching. If I turn on the camera, and I'll just hit W for the wireframe, I'll turn off the grid here. We can see that this geometry, for the most part, lines up pretty good. And this is just so I could have some interactive, you know, aspects for collision and such. So from that, I had to create a flip source. Let me go back into 3D here. And all this really is just taking the top portion of this spout SDF here. There's a random step in here where I had a transform before it gets booleaned. It's the kind of like center area here. So I'm just taking the top or bottom portion of it, essentially, flipping that out, and then filling this in as a kind of shorter box, but it still aligns within that space. So this is the interior of that channel. I'll even template this so you can see the alignment of that. Basically clip the front, the back, polyfilled it, and this is just keeping it procedural. That way, if I change one, this will update along with it. Shrunk the geo, threw a mountain on it, and subdivided it just to give us an interesting shape, and animated mountain on that, just so it has some kind of movement, so that source varies every single frame. I made a container that roughly is going to encompass the overall simulation. The sources within that. I bring that up. The source is right there. And that all goes into a flip container. And this container is what's driving that. So it automatically connects up to that. And from that, I just set up a flip boundary with that source. And that gives me my source here. Hit W. So that's my actual emission source. And then my collider is going to be that other geometry that I had up top. So that's just navigating back up to that. And then the flip solver itself. Nothing too crazy on this. I sped up time a little bit. Splashy for the flip setup. There's no reseeding. I've changed the visualization and also got rid of narrowband in this particular case. And did some cleanup here. Blasted out the volumes that you get from it. I just wanted the particles, and ended up with a simulation like so. And then from that, I just did my own meshing. Instead of the particle fluid mesh, it uses a similar concept. It just has all of the flashy extras and bells and whistles. I didn't need that. I just did a VDB from particles, converted that into a mesh, transferred my speed and velocity attributes over to this. So these are just mappings that I have that I can use for emission later on, as well as this ambient occlusion, which should be this one. There it goes. So I can use this as kind of like white cap areas to emit from some mist and so forth. So I'm just using that as a simple, mask by ambient occlusion. It's fairly heavy, so I cache that all out. So now I have all of this information right here. From that, I just created an emission source by setting an attribute on that, and that's basically for the pop simulation, so it knows where to emit from. I don't think I have that as a actual visualizer, but I can pop this up and turn this on. And that's basically limiting to not emitting until after this point. So anything down below here can be missed emitting off of that. I wanted to prevent it from coming from the upper portion there. So once I did that, pop sim. And this is basically just using some pop forces to waft off some of the particles that are across here. So we get the emission coming off of that mapping, and then we have like some lighter particles that kind of drift in the air, essentially. Just to show some of the setup in that, there's some randomized mass, some pop drag, some kill geometry just to get rid of some overspill that was happening. The wind force in there is set based off of height, using the Y value. And then I threw in some vorticles that are using some geometry or some points geometry that I made separately. And it's referencing that to create kind of vortical spins. To the right here, these are the vorticles. They're just a bunch of points in 3D space. So this is where like it spin around this way, spin around that way. There's randomized angles as to which way things are spinning. Again, I don't have a visualizer for that, but that's where the axis and all of this information is coming from, where that spins around. So the mist, once I have that coming off of there, I just set some coloring for it. And then I set some alpha as well. Some parameters that I'm going to use in render later on. So the alpha as well as P scale. If I turn on lit spheres, we'll see the actual scaling. The lighting in here is also messing with that a bit. That's with shadowing on. This is not with shadowing. Lit spheres can be a little tricky sometimes because it is an actual 3D sphere. So if I zoom that in, that's what it's doing, is lighting that. Just keep it on pixels so we can see it. Did some cleanup, and that pretty much covers all of the liquid portion of it. Rendering wise, I did use the particles as well as the mesh. It's kind of like a hybrid approach. Over on this side are the plants. The output of that, so turn this on here, is basically this whole front face. Everything that's down in there. I'm going to zoom this in. Shadows don't work when you zoom in, so it gets a little funky sometimes when I do that. But so all of this geometry was just generated on the front here. Basically using both structures that I had. So this upper and lower for the spout, I did some bounds, the Boolean that out just to create a front face that I would have a zone for where the actual seeds for these plants would go. So I'm scattering some seeds on there. Let me turn on the points, and I'll actually take the camera off so you can see right there. So that's what all of those points are. Giving them some p-scale, giving them some randomized directions. That is so we can have angles, essentially. So the directions, we're going to be having the leaves kind of like facing and in different directions and so forth. I'm modifying it just so they're kind of all going in a specific kind of direction, but still randomized at the same time. I didn't want them to go back through the actual geometry. And then doing some renaming and then copying some lines onto that. These are basically the initial kind of branches. So these are the main stems that I then scatter some more onto, create some more attributes on there for randomizing direction, and then copy some more lines onto those. And then throw in some noise, and now I have my branch structure. And these are just random kind of branch areas that I'm going to put leaves on. From that, I'm creating some leaf directions and information. That gets scattered some points. These are going to be the leaves. Same for a lot of the transformations for which way these are oriented. I did a custom setup here so I could set my up and N attributes. That way, once we get down to the copy, the leaves are twisted in the directions based off of that. Without this, they all copy on those curves. So this has helped spreading things out as well as twisting them so they're in, randomized directions. The p-scale obviously changes the scaling, and the color is the color. Turn off the back face so we can see more of the greens and yellows that were in there. And I just color picked. Every time I went in here, I just color picked from the actual footage, trying to grab some of those nearby geometry or the nearby leaves that were there. I threw in an additional noise just to mangle these up a little bit more, just so they weren't so flat. So there's the flat geo versus the new kind of wrinkled looking geo. But nothing too crazy. It's pretty straightforward. I have the stems these are going out just so we can get the randomized color of this, as well as setting the width on the stems for that. And then I have the render. The comp export was nothing crazy. This was just converting the EXRs to JPEGs in here. So that was nothing fancy going on there. But this brought in, set this back to here. And this likes to act up. We hop back out and go back in, and it's still going to do it. I'm going to keep refreshing until I probably start a render here. Let's do XPU. Yeah, I'll give that a second. Basically, I've brought in water. Take it to around frame 120 here. Give this a second. Yep, just thinking. There it goes. My GPU is between the screen recording and the rendering, it's getting a little heavy. So the leaves, I have the water, the mist, the matte that comes in. That matte, turn this off real quick, is going to be this geometry right here. And that's just so I can crop out the water correctly on the top arch and on the sides here to match what the footage was. If I think I have, if I put down a null, I can probably do it this way. So I want to match the arching that's in there. So I'm basically masking out my geometry by using this piece of geometry. So I have the water particles. The mist is all of the kind of particles going off to the side. The geometry for the water. I have the plant leaves, the plant stems, and then I have the shadow catcher, which is just here to catch all of the shadows that happen against the wall. Go back to this real quick and turn this on. So you'll see on the side over here, there it goes, the shadows of like the leaves coming in. So that lines up with the shadows on the actual like footage. So that's what that shadow catcher is doing, is it's blocking some light and catching all of that. The split that I have going on here is basically I just have a non-material version. So this is just the proxy grayscale of all of the elements. Down here is a background plate. I did live compositing, as it were. Everything was baked out in the render. I didn't do any post compositing at all. So the background plate is getting basically the background footage. It's using the matte as a holdout primitive. So that's intentionally grabbing that matte to do the cropping. So it knows to project the footage onto that geometry. Connecting this up to the second input here for Karma render settings, and enabling import render vars from second input on the image output AOV tab. That will bring the background plate into the render settings. Below this is the render settings edit, and on the Karma tab, use background. If you turn this on and force it to be on, this will bake the background plate into the final render output. So those three elements are working together. The primitives, you want to put a star in there to grab everything above. And I think that's all you need for the background plate to render. It's basically have the plate, if they're already mats to hold out, connect it to the second input, turn this option on here, and then do the render settings edit. Use background on. As long as that's all set up, then you should get the background plate rendered out with it as a flattened piece. Normally you don't want to do that, but for this I just wanted to knock it out in one piece, and I do everything kind of in camera, as it were, for this particular scenario. But this is the dam with plants track shot. So that should cover everything. I hope you learned or found something interesting in this, and I want to thank you for watching the video.